In the fast-paced world of semiconductor manufacturing, the journey from a chip design to the market debut is a race against time. Today, we are at the brink of a transformative leap, where artificial intelligence stands to become more ubiquitous than ever. Automated testing equipment, AT, systems are an important part of chip manufacturing flow, tasked with testing new silicon chips for defects and ensuring they meet rigorous specifications and standards. This phase, known as bring up, is vital but time-consuming, relying heavily on predefined test patterns that may only catch some possible errors. But what if we could make this process more intelligent, faster, and efficient? Enter AI-driven ATE, a game-changer that promises to slash testing times and elevate chip quality. Through adaptive test strategies, AI can optimize test sequences in real time, homing in on anomalies and adjusting parameters for unparalleled accuracy and coverage. It is just the beginning. Imagine predictive maintenance that foresees equipment failures before they happen, minimizing downtime and keeping the production line moving smoothly. Or advanced defect detection, where AI algorithms discern subtle irregularities that human eyes might miss, ensuring that only the highest quality chips make it through. The power of AI extends rapid data analysis, dissecting vast volumes of test data in a blink, pinpointing defects, and identifying areas for improvement. It accelerates the iterative process of testing and refinement, making it faster than ever before. AI-driven ATE systems are not just tools. They are learners. With each test cycle, they grow more competent, streamlining their effectiveness and efficiency. This continuous learning curve is invaluable for testing innovative chip designs. Moreover, AI can revolutionize test pattern creation, automating this complex task and significantly reducing the time and expertise needed to prepare comprehensive test suites. Efficiency is critical, and AI excels here, too, optimizing test scheduling and resource management to ensure peak operational performance. With AI, fault classification and diagnosis reach new levels of precision, offering critical insights for designers to refine and enhance chip designs, streamlining the path from troubleshooting to perfection. Customizable and scalable AI algorithms can be tailored to specific chip designs and technologies, growing alongside the evolving landscape of semiconductor manufacturing. Integrating AI with ATE systems does not just streamline testing. It creates a seamless information flow from design to production, accelerating the transition from concept to market-ready chips. Yet, this journey has its challenges. The road to AI-driven ATE integration is complex, from the need for vast data sets to train AI models to considerations around data security and the demand for specialized skills. As we stand on the cusp of this new era, integrating AI into automatic test equipment heralds a significant leap forward. It's a shift that promises faster time to market and a new standard in chip quality and reliability. The future of semiconductor manufacturing is here, and AI powers it.